Let's continue in section 1.3. I have one more example where we want to multiply two complex numbers. You might pause the video and try to do the problem for yourself, or we'll go together right now. So 9 minus 7i times 9 plus 7i. We want to distribute. We're going to do 9 times 9 is 81. 9 times 7i is plus 63i. And then minus 7i times 9 is minus 63i. And minus 7i times positive 7i gives us a negative 49i squared. And then do you remember that I squared is the same as negative 1, and so negative 1 times negative 49 is positive 49. And then that positive 49 gets added to the 81. I believe that's 130. And then the two middle terms can be combined. Plus 63i and minus 63i, they actually cancel. And so we're just left with 130. So here's an interesting example where we multiplied two complex numbers, and our answer is a complex number, but notice that the imaginary part has fallen away. When we think of a complex number, remember we say it's a number of the form a plus bi. And so here, the value of b is 0. It means that our answer is a real number. Our answer is a real number. Okay, so let's go ahead and go on to the division now. And oftentimes when you see instructions to divide two complex numbers, there's a reminder to write your answer in the form a plus bi. And so what you have right now is you have a plus bi in the numerator, and you also have another a plus bi in the denominator. And so what we need to do is we need to find a way to get I out of the denominator. If our denominator were just a single, just had a single term, if it were just a real number, then we could distribute it to each term in the numerator and we'd have our answer. So that's a lot to think about. That's a lot to process. Let me go step by step here and show you how that's going to work. So what we're going to do is we're actually going to take a cue from the previous example. In the previous example, we multiplied 9 minus 7i by its conjugate. The conjugate just means that it's exactly the same as the first factor, except for the sign in the middle is switched. And then the result is that the imaginary part falls out of the answer. And so what we want to do is we want to multiply the numerator and the denominator by the conjugate of the denominator. So this is a big idea. It's the first step in the problem. It's essential to understand this in order to get these problems correct. So what is the conjugate of the denominator? Instead of 3 plus 2i, it would be 3 minus 2i. The same two terms, but the sign in the middle is switched from positive here to negative over here. And then, of course, we're allowed to do that as long as we multiply by the same thing in the numerator. And then, of course, we're just multiplying two fractions, and we know the rule to multiply two fractions is to multiply across numerator times numerator, denominator times denominator. So now this turns into the multiplication that we've just been practicing in the previous examples. Let's go ahead and multiply out the two numerators first. 9 times 3 is 27. 9 times negative 2i is minus 18i. Minus 7i times 3 is negative 21i. And minus 7i times minus 2i is positive 14i squared. Okay. And then in the denominator, we would have 3 times 3. We would have 3 times negative 2i, which would make minus 6i. And then right after that, a plus 6i to cancel with it. And then the last term would be a minus 4i squared. Okay, so now let's see how all this cleans up. Let's go ahead and, I don't know, let's work in the denominator first. We have a minus 6i plus 6i, and then minus, they cancel. There's a minus 4i squared, which is just plus 4. And so your denominator now is just 9 plus 4 is 13. And then in the numerator you have a plus 14i squared at the end of it. That's the same as minus 14. So you have 27 minus 14, which is 13. And then you have two middle terms, minus 18i minus 21i, which is minus 39i. And so this is what looks really good. This is what I was trying to talk about at the beginning of the problem. In the denominator that we started with, we have a complex number. We have two terms, the real part 3 and the imaginary part 2i. And now, after some special multiplication, we got to a new form of the same number. And in this new form, the denominator only has the real part. The imaginary part has fallen away. And so now we can just distribute that 13 in the denominator to each term in the numerator. So the numerator 13 divided by 13 minus 39 divided by 13. And then you could put the I in the numerator, or you could put it after the fraction. And the last step is just to simplify, if it's possible. In this case it is. 13 divided by 13 is 1. 39 divided by 13 is 3. And so our answer is just 1 minus 3i. Notice that this fits the form a plus bi that we were looking for. That means that we have a complex number. Okay, let's do one more of these just to see it again. It's kind of a tricky problem, so a little more practice certainly wouldn't hurt. Okay, so let's make up a new problem. Let's do negative 6 minus 2i over 1 minus 5i. And so the instructions say divide and write the final answer in the form a plus bi. So the key now is to multiply by the conjugate of the denominator. So let's go ahead and try that. Let's do the conjugate is 1 plus 5i. If you like, pause the video and try to work on through the problem, or follow along with me. In the numerators, we have negative 6 minus 30i minus 2i minus 10i squared. And in the denominator, we have 1 plus 5i minus 5i minus 25i squared. We can simplify the numerator. We have minus 6 plus 10. Minus 6 plus 10 is 4. And then the two middle terms make a negative 32i. And then in the denominator, the two middle terms cancel, and we're left with 1 plus 25, which is 26. So now we know we're doing well because the denominator just has a real number. And so we can distribute that to each term in the numerator. And then we can simplify. And we would get 2 over 13. Let's see, that's 2 into the 4 goes 2 times, 2 into 26 goes 13 times, so that looks good. And then if we did 2 into 32, we would get 16, and 2 into 26, we would get 13 again. So for our final answer, we have 2/13 minus 16 over 13 times I. Okay, so that covers the division of two complex numbers. We have one more video in this section where we'll just talk about sets of numbers.